Okay, before I start this lesson, I actually just want to write something down that helps us differentiate a little bit. This is something you would want on a study sheet, but I just want you to look at this little picture here. I want you to draw, oops, sorry, let's go to the top of the page. I just want you to just at the top of your page draw this graph really quickly, and through points -3 and -2, draw this graph, okay? So -3, -2. Now, this is to be able to keep this stuff straight. Now, what are the factors of that equation? No. Close. You got half of it. The factors would be x plus 3, x plus 2. Okay? Very different from the zeros, which equals roots, which equals x-intercepts, which would equal -3 and -2, right? So factors aren't the same as zeros, roots, or x-intercepts, but they are closely related, and sometimes we're going to get those mixed up. So this is something I would have on a study sheet because I don't want to get these mixed up. Like when they ask me the factors, I don't want to go, are those the same thing as roots? I want to have that in my head going, no, 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 I know factors were not the same thing as zeros, roots, or x-intercepts. Okay? But the factors were actually, I guess, if you kind of look at it, that they're opposite in a way, right? They're kind of opposite of factors. Now, as we're going through that, I want you to kind of keep that straight, because actually the book messed it up, and so I had to even go through and correct some of the notes in the book from the publisher, because they had said they had got factors and zeros mixed up. Okay? Now, I'm actually going to go right down to here, and let's talk about investigating the integral zero theorem. That's what we're going to be talking about today. Okay? Now, if I was to factor this equation, I would come up with the factors x plus 8, x minus 3. Okay? Now, what kind of generalization can we make is that, you know, when you multiply the numbers together, like if it was x plus 3, x times 2, x plus, if I was just to multiply the numbers together, what do I get? I'll get always the constant. Now, right now you guys are probably going, yeah, so, okay. You're going to see where this comes in handy, because with x squared, that doesn't look like that's great help. I had to figure those out anyway. But what we're going to be learning is that when you look at this, what do you notice about all of these? When you multiply them together, what do they equal? So when you multiply them all together, they will equal the constant. So what if I just gave you this and I said, factor it? A lot of you guys might be like, like what? How do I factor that thing? I don't know how to factor that thing. Well, I'm like, well, guess what could be factors? What do you mean guess? There's 10 billion numbers out there. How am I supposed to guess? Well, maybe look at this. What could be some of the factors? And when I ask you some of the factors, there is millions of them, but how many integral ones are there? Very few. In fact, what would be all the factors of 2? What are all of them? Anyone? There's plus or minus 1, plus or minus 2, right? There's not that many of them. So now I could divide by x minus 1. And if it works out, I got one of them. Okay, so maybe I'd have to test all 4 of them. But once I got 3, I'd be pretty good. Now sometimes those could be like real numbers, like 0.38 and 1.36. Like if you multiply those together, those equal 1, right? Doesn't sound like it, but it does. It works out to be something close to that. So, but in the 30-1, it's nice enough that at least one of them will be integral factors. Okay? So, what do we know about the constant term? The constant term is the product of the factors, okay? We need to know that because, or product of the product of the factors, we'll just say that, okay? So I want to start showing you what I mean by how we're supposed to do something like this, okay? And actually, if we look at just this one here, here is all of the potential factors, or you could also look at the potential zeros. Remember, zeros were opposite, but when you're dealing with plus minus, what's the opposite of plus minus 1? Minus plus 1. So you actually come up the same ones. Okay? Just got to keep it straight when you're putting it in your answers. So all the potential zeros of 6, now these are potential zeros. It's not all of them, but these are potential ones. It could be these. We're not saying for sure they're all of these, because they're not. But if these are the potential zeros, what could be the potential factors? Okay, so list all the zeros of this. Let's go down to example 1. All the zeros of this. I look at this thing. What are all the potential zeros of the polynomial? Well, I actually list the numbers first. So I know 1 goes into 6, 2 goes into 6, 3 goes into 6, and 6 goes into 6, right? Then I just do this. Because I know that it could be plus minus, plus minus, plus minus, right? Now, what would be all the potential factors? X plus 1, x minus 1, x plus 2, x minus 2, x plus 3, x minus 3, x plus 6, x minus 6, okay? So, and it's not going to be all of them, because if you multiply all those together, you're going to get, x to the 8, if you multiply those things. So it's just 3 of them. Now, how can you find out if any of these would be factors? What are ways to do that? Take the number, put it in, and if it equals 0, it's a factor, right? Now, I know you're sitting there going, well, that's kind of like lame, like you're just guessing. Guessing test, guess test. Now, that's mathematical thinking at its best, doing that, okay? When I give you a formula, and you kind of don't know what the formula is, but I know to shove it in that formula, I get that. But it's actually not very mathematical, okay? A lot of people know how to, if I said fill this box with this stuff, a lot of people could do that, and without actually doing math. If I said, here's a bunch of stuff, how do I transport it, and you come up with 4 different ways to transport it, that's mathematical thinking. Okay? Filling the box is not mathematical thinking. Okay? So, let's go right to example 2 up here. Here is the polynomial that we need to factor. Now, this isn't easy to do without knowing these little tricks. But do you know that if I can chip away at it till I get it down to an x squared, and I know how to factor x squareds really well, because we've been doing them since like grade 9, right? You can use decomposition. You can use the quadratic formula. It's easy to do, but when I'm at x to the 4, x to the 5, or whatever, I got to keep chopping it down until I get to that stage. Now, this is the number we look for. Now, what are all of the factors of, or zeros, potential zeros of 12? What are they? List them off. 1, 2, 3, 6. Am I missing one? 4, 6, 12. And then go like this. Now, then it says, express the polynomial in factored form. So I need to factor this. And I'm going to get 4 factors. Why do I know I'm going to get 4? It's x to the 4th. If it was x to the 5th, I'd get 5 factors. Okay? If it's x squared, you'll get 2. So I don't have to guess all 4. Because it may be two nice integers, and the rest could be some weird number like 0.33 and another one 1.28. But the curriculum, the 30-1 curriculum, is nice enough that you'll be able to find, if it's x to the 4th, you'll be able to find 2 of them by testing. If it was x to the 5th, you'd get 2 of them, or 3 of them by testing. You'll always get it down to an x squared by testing these. Now, what's an efficient way to test these? What's that? Factor theorem, put them all in. Okay. What's an efficient way to use the factor theorem? Yeah, get into the store x. Now, that may not seem like very clear to some of you. So this is how you do it. Okay. So the first one I'm going to try is 1. So you go 1 stow x. Okay. Got it. Now, put in the equation. X to the 4th plus 2x cubed minus 7x squared minus 8x plus 12. Okay? And then you can press, did I do it right? X to the 4, 2x cubed, 7x. Press enter. That one's a 0. Okay? So keep track of that one. 1 works. Now, here's what I'm talking about being efficient. I don't want to plug this in every time. I got how many of these to check? Right? I got 12 of these things to check. So here's a quicker way to do it, is you can go and do -1 stow x, enter. Now, hit second, enter, second, enter again, and it actually, even though it brings back the old equation, it still keeps -1 in there. And then hit enter. -1 is not a factor. Does everyone get what I'm doing here? Okay, this is a quick way to do it. Then go 2 stow x, enter, get it in there, and then go second enter to bring back that equation, then hit enter. Hey, 2 works too. So far I've got 1 and I've got 2. Okay, now that's all I need. I'm not going to mess around anymore. Okay, so I know 1 works and 2 works. If you get 2 of them when it's an x to the 4th, stop. Don't keep going through all of them because it's actually least efficient. Because what if 12 is one of them? Now it shouldn't be, because 1 times 2 times the other 2, I'm not going to get, well, yeah, 12 is not going to be one of them. I don't know if you guys are seeing what I'm thinking, right? But anyway, let's try putting 1 into this. And I'm going to chip this thing down. Now, I'm really, really glad that they put synthetic division back into the curriculum, because I always had to do this with long division every time, right? And I had to, so students got good at it because it was on the diploma. But we've done enough of long division, let's do synthetic. So I'm putting 1, 2, -7, -8, 12, Everybody's there. Nobody's missing. I don't have to put any zeros. Drop the 1. 1 times 1 is 1. 2 plus 1 is 3. 1 times 3. 3. Negative 7 and 3. Negative 4. Then a negative 4 up there. Negative 12. 1 times negative 12 and 0. Okay? So that works, but that's not what I was going for. So now I know x minus 1 is one of the factors, and I have my new equation. Now this is 0, 1, 2, 3, right? So that's 1x cubed. Well, this is what I can do next. So I'm going to actually put this one, 1, 3, negative 4, negative 12, in. And I found my other factor. Remember, that was 2. 2 goes into this thing. Then I get my, drop my 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. Negative 4, 10 is 6. 2 times 6 is 12. Negative 12 is 0. So I have proved that x minus 2 is a factor. Now see, once I have it to this stage, 1x squared plus 5x plus 6, I know how to get those. I know how to get those now good enough that I can be quite quick. So what are the factors of this quadratic? What goes, adds to 5, multiplies to 6? Because 5 plus 1 is 6, right? Yeah. So x plus 2, x plus 3. So my final answer is, well, let's state the zeros. So the zeros would be 1, 2, negative 2, negative 3. Actually, number 1, or B, I haven't finished yet. I haven't done it in factor form. So in factor form, it would be x minus 1, x minus 2, x plus 2, x plus 3. This would be in factored form. So I chopped it down till I got to the x squared one, and then I just used my factoring. So the curriculum is very good at making sure that you can chop it down. Now maybe that x squared wouldn't have been a nice one, but I could have used quadratic on it. I would have had the 2 nice ones, and whatever I got left with a quadratic. And we're going to do one of those next. Okay? And what are the roots? Well, the roots, same thing as 0. So I hope we're putting the same answer. Okay, so today's kind of bringing all that stuff into one area now. So today's a pretty nice day, you'll find. Now, here we go. This one says factor it. Okay? Now, it says find the zeros using the graphing calculator. Well, we're not going to, because we're so awesome, we don't need it. So, what would be all the factors that I will be looking for? What are they? Plus or minus 1. It's a nice day when that's all you got to look for. Now, what is weird, and you'll see with this one, is that there's got to be 3 factors. Right? It's an x cubed. But I've only got 2. Well, there's about 10 bazillion factors of 1. These are the only integral ones. So the only way I can chop it down, and the only way that I would be expected in 30-1 to do this, is to have integral ones to chop down. I can't look at that and go, well, you know, 0.27 and 3.73, those are factors. Yep. Okay, that's a little bit, you know, a little bit extreme. So we're going to test plus or minus 1. Okay, so go to your calculator and find out if those go in. I guarantee one of them or both of them is going to go in. So I'm going to try negative 1 first. So x cubed minus 3x squared minus 3x plus 1. I hit enter. Okay, that one works. Okay, so I found 1, and all I want is 1, so I chop it down to x squared. Okay, so negative 1 works. Okay, so let's do some work. So negative 1, remember that is my 0, not my factor. So, and I'm putting in it to 1, negative 3, 1. Okay, so, brought down my 1. That's negative 1, negative 3, negative 1 is negative 4. I multiply those two together, I get 4. Negative 3 and 4 is 1. Negative 1 times is negative 1. Add those together, I get 0. Good. Okay, so x plus 1 is definitely a factor. Negative 1 is a 0. Now I have this, 1x squared minus 4x plus 1. Now what are two numbers that multiply to or add to negative 4 and multiply to 1? Okay, that's not nice. But this one would be a good one for higher level in the diploma. Okay, because you can't solve it with your calculator, but you can sure check it. Okay, and we'll see how to check it right after. But I am going to be doing my quadratic formula, right? Negative b plus or minus b squared minus 4, or square root of b squared minus 4ac over 2a, right? So we won't write that down. We'll go right to the formula. So it's negative b, which is 4, plus or minus the square root of b squared minus 4 times a times c. This is a, this is b, and this is c, right? All over 2 times 1, which is a. So you get x equals 4 plus or minus the square root of 12 all over 2. Okay, can I do any simplifying with square root 12? I can take out a 4. The 4 comes out to become a 2. So then I get 4 plus or minus 2 root 3 all over 2. Now see I can divide the 2 by everybody. So then I will get 2 plus or minus root 3. So the zeros are negative 1, 2 plus root 3, and 2 minus root 3. Okay, now if we graph it, let's see what's going on here, because this doesn't seem right. Those numbers are bad, right? They're not nice numbers. So I want everybody to try graphing it here, not just me. So x cubed minus 3x squared minus 3x plus 1. Okay, and let's hit zoom 6. So we're all looking at the same graph. Okay, so these are supposed to be my x's. So this one here, that's my negative 1. I'm good with that one. Let's find, now, because I love doing intersect, I'm going to hit y2 as 0. Now, you don't see it, but it's there. And then I'm going to hit second trace, and I'm going to go 5, intersect. Now I'm going to get my spider over to close to that and hit enter 3 times. So 0.267 is one of them. Maybe I'll do a screenshot of this and have it there. Okay, so that's that one. And then go back to here. And I want to now, I'm going to go second trace there. I'm going to hit 5, intersect again. And I want to get over here and get that one. Enter, enter, enter. Okay, 3.73. Now, I like this question because it comes up with the zeros we would not have thought of. Okay? But you got negative 1 times 0.268 and 3.732. If you multiply that all together, you should get actually negative 1. You'll always get the opposite because these aren't our factors, right? These are our roots. But if you multiply those together, you actually should get, let's try this, second quit. So if I go negative 1 times 0.268 times 3.732, it is negative 1. Okay, and that'll always be the opposite. Sometimes it'll be the same when it's even, but what I'm trying to show you is that if you put those in factors, which would be x plus 1, x minus 0. And x minus, then you would actually get the true one. But you can see how decimals make, when you multiply, make 1. Okay, and you're not coming up to those by guessing and testing. Okay. Now you could graph it and you could do it that way, but you got to think the book is, or the my test and the diploma hopefully are going to be creative enough to be able to make you have to do it without a calculator. So we're doing 1 to 6, 10A, and 11 to 13. Okay, everyone's got that down. I'm just going to scroll through so people at home can do their homework. Okay, and there is a mistake in the answers. Not in the solution manual, but in the book. I think it was, what, 2 D and E. Get all those down so I wouldn't see them. 2 D and E. What was the problem? Yeah, these should have been positive 3s in D and E. Now they are correct in the solution manual, it's just wrong here. Okay, let's go.